Hi and welcome back. Tonight's notes are going to be on page 67. And this is going to be on tangents. And not the tangents that we've been talking about with angles, but this is something in circles. So let's draw a circle. So that's our circle with center at C. So what a tangent line is, it's a line on the outside of the circle that touches in one place. So let's say it touches here. This is our tangent line. Okay. And it touches in that one place. That one place is called the point of tangency. Now, when you have a tangent line, there's some specific rules that go along. So first off, the first thing is a line is tangent to a circle when it intersects the circle in exactly one point. And that point is called the point of tangency, like we already said. Okay, so we have a line is tangent to a circle when it intersects a circle in exactly one point, and that point is the point of tangency. Okay. The second thing that happens when you have a tangent a line tangent to a circle is perpendicular to the radius at the intersection point. So we're going to draw what that would look like. We're going to draw a radius so that it intersects at that point of tangency, like that. And it is perpendicular, so we have right angles there. Okay? Radius is perpendicular. So we can see what that looks like on our picture. Okay, so those are the two properties that we're going to use for tangents. So let's do an example. Okay, so go ahead and write that down. It says if PQ, so PQ is tangent to circle C. So we first have that this is a tangent. If PQ is 5 and CQ is 6, what are CP and the measure of PCU? Okay, so let's first put the information that we know on there. Well, the first thing we know, PQ is 5. So that's right here. PQ is 5. Okay. The second thing we know, CQ is 6. So I'm going to draw my CQ, and I know that's 6. Okay. Now the first thing I'm looking for is I'm looking for CP. So CP is right here. Now what is CP? CP is a radius. It's a radius because it goes from the center to a point on the outside of the circle. And then knowing what we know about tangents, what is special about this angle right here at P? It is a right angle, right? Because it's tangent. And we just wrote down that it's perpendicular. Okay? So we're looking for CP. Well, now we have a right triangle. We have 5 and 6, and we want to find this one. So that's Pythagorean theorem. So I'm going to call that X. Now, when we use Pythagorean theorem, that'll be x squared plus 5 squared equals 6 squared. And I'm going to write down Pythagorean theorem so that you remember that's what we used to solve that. So that'll be x squared plus 25 equals 36. X is the square root of 11. So CP is root 11. Okay? Now the next thing we're looking for is angle PCQ. So angle PCQ, that looks like that. So that's right here. That's the angle we're looking for. Okay? PCQ. We're looking for an angle in a right triangle. How do we find an angle in a right triangle? We use trig, but we're going to use the inverse trig. Okay, so I'm going to write to find the angle in a right triangle, use inverse trig. Okay, so what that's going to look like is, let's call this angle y. Okay, now looking at y, I want to use the 5 and the 6 because I don't really want to use the root 11. So if I want to use the 5 and the 6, that's going to be opposite and hypotenuse. So that's cosine of y equals opposite over hypotenuse. And then we need to take the inverse. So that's going to be cos inverse. So we get y equals cosine inverse of 5 over 6. And you put that in your calculator. And we get y equals 33.56 degrees. So this is 33.56 degrees. Okay, and that's when we can use tangents. We can find sine lengths and we can find angles. All right, thanks for watching.